Hi students, this is Ramkishore, faculty in ECE department, DBSIT, Kavali. So in today's class, we are going to discuss about one more topic in VLSI design styles or subsystem design. Those are nothing but we have to design the basic function of comparator. So what is a comparator? The comparator it defines, so we have to design a magnitude comparator. So it compares two binary numbers, whatever we applied binary inputs, either it may be a 1-bit comparator or 2-bit or 3-bit 4-bit, whatever the long of the input. So it compares how many inputs are digitally, what is the magnitude of each and every applied input bit of that circuit. So here comparator it compares two digital or binary numbers in order to find out whether one number is greater than or less than or equal to another number. So we are having two numbers within a circuit. So it compares the two magnitude or that applied two numbers physically, what is the weight of each and every individual number applied to a particular circuit. So here we have to design a circuit with two inputs and three output with the conditions are A greater than B or A less than B or A equal to B. So digitally or physically we have to design a specific circuit, so that circuit may consist two inputs and three outputs. So that will be exactly execute the outputs are either it may be applied two inputs or that is applied two binary numbers are equal condition or greater than condition or less than condition. So that will compare by designed n-bit comparator, either it may be a 1-bit or 2-bit, 3-bit or n-bit, whatever the range or length of the bit. So that will specially compares the applied input. So here for the basic diagram or the circuit diagram for a comparator is so this shown diagram. So that this diagram may consist two inputs, those are A and B, and A greater than B. The outputs are A greater than B and A less than B, A equal to B. So how it will be perform the comparison in between one bit to another bit is that explains by this truth table. That is we have A and B. So one time we have to apply one digital input, that is A is equal to 0, B is equal to 0, and in the second case A is equal to 0 and B is equal to 1, and A is equal to 1 and B is equal to 0, and fourth case A is equal to 1, B is equal to 1. How it compares means, so we are having some mathematical calculations or comparison. So here A is 0 and B is 0. So that means two bits or two physical weight of these two bits are same, that is 2 represents 0. So that at this condition it represents A is equal to B. So based on that condition, so it will compares the two bits and assign this formula, that is A bar B bar. For example, we can consider two conditions. That means for this one A bar B bar, A is B bar plus AB plus AB. So by using this formula we get this result, A is equal to B1. For the next condition also, if the both A and B are equal to 1, so and at that condition also 1. So based on this condition we have to write a resultant K-map equation. The resultant equation is, so here A and B, if the real or if both inputs are high, then we can consider A, B, and if the imaginary, that means if they have inverter function inverting, then we can consider A bar B bar. So whenever we consider vertically in this line, then we get this resultant. That is in both the cases, whether A bar B bar or AB, we get A is equal to B. In same the condition, if we consider A less than B or A greater than B, so that will not possible for these conditions. That is in case of 0 or in case of 1, because so both are equal. There is no the physical weight of the bits are not differ from one to another one. So whenever the difference is either it may be less than or greater than. So next second case, consider the second case. So A is 0 and B is 1. B is 1. That is A is less than the B because 0 is less than the 1. The magnitude, the physical weight of the 1 is high compared with the physical weight of the 0 is low. So that's why A is less than the B. A is less than the B, and in case we can consider B is greater than A. In both the conditions also we get the A. For that we can consider so that will be possible when A bar into B. The resultant format is A bar into B. So next, and the remaining conditions are 0. Next case, A is greater and the B is lesser, that is A greater than B. So that will be high. The resultant form is A into B bar. So here A is greater than B and the remaining conditions are 0. So next, coming to A, B are both the same physical weight. So then A equal to B and the remaining conditions are 0. So based on that we have to compare. So we have to design a circuit by using different VLSI design style. So this is the operation about comparator. So now we can consider if 2-bit 2-bit comparator. So for that one we have to take A0 and A1 and the B0 and the B1. So we have to compare these 2 bits in a similar manner. So we get the resultant comparator. So it is a 2-bit comparator. In the same manner, so we have 3-bit and the 4-bit comparator. So this is the operation about comparator. So next I am explain another type of circuits, that is CPLDs, complex programmable logic devices. So it is one type of PLDs, programmable logic devices. So in this complex programmable devices, we are having mainly 4 PLD blocks and the input and IO blocks. So here we have the interconnection matrix, so that will interconnection from one block to another block. So whatever the logic or whatever the logic functionality we want or we expose for a specific circuit, so we have to define that logic function within the PLD block. So the integration of several simple PLD blocks with a programmable interconnection matrix on a single chip. So this format is known as PLD block or CPLD block. So the whatever the simple PLD blocks with programmable interconnection matrix will be present within on a single device. So it is called CPLD. So the CPLD is developed based on EEPROM. EEPROM is nothing but electrically programmable read-only memory, and EEPROM, electrically erasable programmable read-only memory technology. In this, the basic CPLD cell is also called as macro cell. So this is whatever the individual cells present. The individual cells present within the PLD blocks, so that is also known as a macro cell. So it is composed of AND gate arrays and it is surrounded by the interconnecting area. So this CPLD offers high speed. Each circuit block is similar to either a programmable AND plane or a programmable logic plane. Whatever, either it may be a PAL or PLA, are connected to set of interconnection wires. So each PLD block is also connected to a subcircuit is called as input IO block. So here the PLD is surrounded or controlled by interconnection matrix and IO block. So this interconnection matrix is either it may be designed, either it may be PLA or PAL. So here which is attached to a number of inputs and output pins to use the pin as the output pin or the input pin. So this corresponding as a, so it will be manufactured or developed with tri-state buffer to suitably enable as input and the output pin. So we have to use tri-state buffer acting as a switch. It turns on if the pin is to be used as a input pin, or the tri-state buffer is disabled acting as a switch when it has it will be acts as a output pin. The interconnection wire contains programmable switches which are used to connect a PLD blocks. So based on that, whatever the logic we have to perform, it may be PLDs. Already we discussed PLA and PALs. So how the logic will be connected from each input to another input. In the same way that logic will be implemented within, but a group of PLD blocks will be is called complexable programmable devices. So these have advantages, low development cost and easy of design, and based on already, so we have to design these type of circuits on printed circuit board. So by using PLD, so we don't want to use printed circuit boards within that device, so that the area of the PCBs also decreases and the speed is increases, and it will upgrade the field upgrading capability is very high compared with another circuits. So this CPLDs can realize complex design. So it name itself, it consists complex programmable logic designs. So it is suitable for complex designs such as graphic controllers and LAN controllers and universal synchronous asynchronous receivers and transmitters. So in short form, you can known as USART. So in those applications, it will be largely it will be plays a important role within the those designs. Okay, next we have to discuss about FPGAs. So another type of PLD circuits are FPGAs. So the full form of the FPGAs are field programmable gate arrays. So here the CPLDs are complexable programmable logic devices. So this one is field programmable gate arrays. So the FPGAs may also have this type of construction, but instead of PLD block, here we have CLB block. So here we have to use programmable logic devices. So those are maybe construct with help of PLAs and PALs. But in FPGAs, so mainly the PLD blocks will take place with the configurable logic block. So it is FPGA is also programmable logic device, but it supports large number of logic functions to implement a large functionality. So if you want to implement a heavy or long logic function, so at the time we have to use prefer field programmable gate arrays. So because it may have three configurable blocks, those are nothing but CLB, configurable logic block, and input IO block, and interconnection switches. So as CPLD consists IO and interconnection matrix, and FPGA also consists the same fields, but so it may change. The FPGA may consist of configurable logic blocks. So these logic blocks are arranged in a two-dimensional array, and the interconnection wires are organized as horizontal and vertical routing channels between the rows and columns of logic blocks. So wherever the CLB is present, so here we have vertical routing and also the horizontal routing for each and every CLB block present in the design. Or FPGAs can be used to implement logic circuits of more than a million transistors in ASICs. So more than a million transistors or million functions within the same ICs, so that is capable to implement within a FPGA. So the features of FPGAs is used in consumer electronics and the security systems, video and image processing circuits, defense and aerospace electronic circuits, wireless communication systems, medical electronic systems, and scientific instruments and distributed monitoring systems, DBS systems. So here in every system, so it will be used in FPGAs. So whatever we have to perform different applications. So for example, when we are describing a camera, so the camera operation, so the overall functionality will defined by using the FPGAs. So the main difference between CPLD and FPGAs are, so FPGA contains up to 1 lakh of logic blocks, while CPLD contains only a few blocks of logic that reaches up to few thousands. So it may based on the CLB configurable logic block. That means each and every logic should be displayed or rotated within the configurable logic block. So based on that application, so that may perform more than 1 lakh of operation within each single block of the CLB. But in CPLD that may not possible, so that may be up to a few thousand of operations will be possible. So and FPGAs are better for more complex applications, while CPLDs are not better for complex, and it is better for simple devices. And the FPGAs are RAM based digital logic chip, while CPLD is EEPROM, that is electrically programmable read-only based logic chip. But it supports, the CLB supports RAM, read and writing memory capability. And FPGAs are more expensive, while CPLDs are cheaper, and the delays are much more predictable in CPLDs than FPGAs. So in terms of architecture, FPGAs are considered as a fine grain devices, and CPLDs are considered as a coarse grain devices. So these are very useful to perform, to place floor planning and floor planning and placement and the routing. So based on this architectures, so we have to use different VLSI design circuits, so to implement most of the circuits within a circuit. Either it may be a synthesis part, or either it may be a simulation. Simulation is nothing but it verifies the functionality of the circuit. So whenever we have to design a AND gate, so it have two inputs, A and B, and the output is A into B. So when we perform these functionality within a CLB block, so that will check. That means whenever we have to do the simulation within the CLB, that whether the unfunctionality is performing successfully or not within CLB, so that will be possible in case of FPGAs. That is not possible in CPLDs. And synthesis is nothing but it produce a gate level netlist to overall the design. So based on that design, so it may if you get successful simulation and the partitioning and the synthesis, so finally we may do the placement and routing of each CLB block, and each for every IO and interconnection matrix by using horizontal and vertical routing. So thank you for watching. Thank you for watching this video, and please subscribe DBS Talks. Thank you.